high above Earth, where the endless blackness of space meets the glow of our planet's atmosphere, lies a remarkable testament to human innovation, the space station. Orbiting the Earth at an incredible speed, the International Space Station is more than just a marvel of engineering. It is a symbol of humanity's quest for knowledge, an outpost at the very edge of our world, and a bridge between Earth and the vast, uncharted territories of the cosmos. Space stations are not just structures suspended in the void. They are essential hubs of discovery, where science, technology, and the spirit of exploration converge. Within their walls, astronauts live, work, and conduct research that has the potential to revolutionize life on Earth and help us venture farther into space. From studying the human body's response to weightlessness to testing cutting-edge technologies, space stations are at the forefront of human progress, providing invaluable insights that will shape our future in space. Space stations have a long history, one that began not with one giant leap, but with a series of smaller steps, each one pushing the boundaries of what was possible. It all began in the 1970s, when the Soviet Union launched the first space station, Salyut, into orbit. This was the first experiment in living and working in space for extended periods, and it opened the door to future space stations. In 1973, the United States launched its own orbiting laboratory, Skylab, which allowed astronauts to study the effects of long-duration spaceflight on the human body and test new technologies that would become crucial in future missions. Skylab's success laid the foundation for more ambitious space station projects. But it was Mir, launched in 1986 by the Soviet Union, that truly marked a new era in space exploration. It became the first modular space station, with its individual components added over time. For 15 years, Mir hosted astronauts from multiple countries, performing a vast array of experiments in fields like biology, physics, and material science. However, the International Space Station, ISS, which began construction in 1998, took the concept of space stations to new heights. With its combination of state-of-the-art technology and international collaboration, the ISS is a beacon of what can be achieved when nations come together in pursuit of a common goal. Today, it continues to orbit the Earth, offering a platform for international science and exploration. Inside these floating laboratories, the possibilities are limitless. Space stations provide an environment where scientists can perform experiments that would be impossible to carry out on Earth. The unique microgravity environment allows for a deeper understanding of everything from human biology to the behavior of materials and fluids in space. Without the constant pull of gravity, new phenomena emerge that simply cannot be observed anywhere else. Take, for example, the study of the human body. Experiments on the ISS have allowed scientists to observe how muscles, bones, and the cardiovascular system react to prolonged weightlessness. These studies are not just about understanding the human body in space. They are leading to real-world applications. Insights gained from how the human body adapts to microgravity can inform treatments for conditions like osteoporosis and muscle atrophy, diseases that affect millions of people on Earth. In addition to human health, space stations play a critical role in advancing material science. The microgravity environment allows scientists to create more pure materials, study the crystallization of proteins, and even develop more efficient manufacturing techniques. These advances could revolutionize industries back on Earth, from pharmaceuticals to electronics. Perhaps the most profound achievement of space stations, particularly the ISS, is their ability to bring together nations from around the globe in pursuit of a common goal. The ISS is not just an American, Russian, or European endeavor. It is a truly international project involving over 15 nations working together to create and maintain the station. Russia, Japan, Canada, the European Space Agency, and many others have all contributed to the mission in ways large and small. On the ISS, astronauts from different countries live and work together in a confined space for months at a time. This unique environment fosters not only scientific cooperation, but also cultural exchange, trust, and diplomacy. In many ways, the ISS has been a tool of peace, demonstrating that even in the most isolated and extreme environments, humans can work together to achieve extraordinary things. The success of the ISS proves that, despite our differences, collaboration in space can lead to discoveries that benefit all of humanity. Space stations are not only laboratories, they are technological powerhouses. Everything aboard a space station, from the advanced life support systems that keep astronauts alive to the cutting-edge robotics that help maintain the station, is a product of years of research, development, and testing. And the innovations developed in space often have applications far beyond the station itself. Consider the Canadarm2, a robotic arm used to move equipment and even capture spacecraft that approach the ISS. This robotic system is not only crucial for the station's maintenance, but has also advanced our understanding of automation and robotics, paving the way for autonomous systems that will be essential for future space exploration. Space stations also act as testing grounds for new technologies designed to improve life on Earth. For instance, water purification and air recycling systems aboard the ISS have led to significant advancements in sustainable technologies, which can be used in disaster relief, remote environments, or even in future human settlements on the Moon and Mars. As humanity's ambitions reach farther into the solar system, space stations will become more crucial than ever. While the ISS remains the heart of space research, future space stations will extend our reach to new worlds. NASA's Artemis program aims to return humans to the Moon by 2025, and with it, the establishment of a permanent human presence on the lunar surface. The lessons learned from the ISS about living in space, about sustainability, and about cooperation will be directly applied to the lunar base that will serve as a stepping stone for further exploration. Beyond the Moon, Mars is the next destination. But living and working on the Red Planet will require us to develop new technologies and strategies for surviving in a hostile environment. Space stations will play a pivotal role in preparing astronauts for these long-duration missions. For instance, the Lunar Gateway, an orbital station planned to be established around the Moon, will serve as a staging point for future missions to the lunar surface and beyond. Space stations are much more than just platforms for research. They are a reflection of humanity's unyielding desire to explore, to innovate, and to unite in the face of challenges. They remind us that space, once thought of as an unreachable frontier, is within our grasp. Through space stations, we have learned not just how to survive in space, but how to thrive. As we look ahead, space stations will continue to be our lifeline to the cosmos. They will be the launch pads from which we explore the farthest reaches of our universe. They will be the places where we perfect the technologies that will sustain life on other worlds, and the bases from which we will chart humanity's journey to the stars. In the grand tapestry of human exploration, space stations stand as one of our greatest achievements. They are a testament to what can be accomplished when nations work together, when science drives our ambitions, and when the spirit of discovery propels us into the unknown. And as we look toward the future, we can be certain that the role of space stations, as both laboratories and springboards for the human race, will continue to expand, pushing the limits of what we can achieve and helping us build a future beyond Earth.